Okay, hello, good morning, everyone. Um, so I won't expect anyone to tune in, but I still wanted to stream this. Thank you so much, Royal Librarian, for the follow. Um, I really appreciate it. Appreciate it kindly. I messed up my green screen here. Let me. So it's correct again now. Um, So yeah, thank you so much for the follow. I just rolled out of bed, like I literally just rolled out of bed. I got downstairs, I got a coffee. But I think while I look the worst on this at this day and hour, I think my mind is the sharpest. While I might not look like it. So what I want to do now is I want to try and see if I can program in the the generative adversarial network. So um, I'm gonna open our main file. So I'm gonna open our main file because we already did some stuff in there. So we loaded in the data. So this is like loading in the data. I should probably make a script for this. But all we need to do is like three things. So we need to create the generator. Then we need to make the discriminator, and we need to make the prior. So we need to specify the prior for the noise, right? Specify the prior for the noise. Now, in general, I have a proper idea of what the generator is gonna be. So the generator is gonna be a neural network with a single hidden layer with a to be specified amount of nodes. The discriminator is also going to be a neural network with a single hidden layer and a specified and a to be specified amount of hidden nodes. Good morning, guys. I hope you're doing well. I hope you guys are having a great night or a great morning, depending on where you live. I like literally just rolled out of bed. I woke up. I got a coffee, which I have here, which I almost finished, and I want to really finally start coding this in because I did one session yesterday evening where I wrote this document, which is like kind of a guide on what is a GAN and how to make it. And I think it's very useful for someone who is new to machine learning but has general math chops to understand it, but just wants a quick overview of what a GAN is. I think that the idea is very important. And the paper is a bit tough to read and light on details, but we were able to figure it out together, or at least I like to think so. Okay, so step one, like the very first thing we have to do is we have to make the prior, because we need to we are going to need to so training the discriminator is just training a neural network, but with different layers. Not with different layers, but instead of like usually you have X and Y, where X are features and Y is the label, 0 to 9, because it's the number, right? So we are classifying handwritten digits. But right now we have X is X and Y, or we can say X and R or X and Y. We have X are the features, but Y is true, is like real or fake. So either it comes from the training set or it comes from our generator. Okay, so the first thing we have to do now, so top priorities, is kind of figure out how to specify the prior using the training data. So we have to make a prior in this image. We have to generate random noise. While the noise is random, we do impose some structure on it, as seen here. So the prior probability distribution of the randomly generated noise is PZZ. So now we have to ask ourselves, like, okay, so how do we choose PZZ? So let's Google that. Or actually, I saw this. So we ended the stream yesterday by looking at this guy, and we're gonna use his equations because his equations we're not gonna copy them because we are using different activation layers, but we're going to use kind of the chain rule and the cost functions that he uses. Because why reinvent the wheel, right? So random int. So let's see. So this is the generate. No, I won't go into too much details. Our images are 1784. Random int is len images -5. Current images. First generate the first fake data. Feed forward for real data, feed forward for fake data. Cost is D. Yes, okay, so what we're having here is, so he generates just random uniform data between -1 and 1. I'm not sure why there's a dot here. -1 dot, minus and 1 dot. So this guy, I'm gonna copy this thing here. This guy just takes it uniform. Let's name it Jaidukseo. Jaidukseo takes it PZZ to be uniform -1 1. Okay, now I'm gonna Google that. Like, how do we choose prior for a GAN? How to choose GAN before noise prior in GAN algorithm from Reddit. A prior, so he has a question here. From the noise prior, I think this should be GZ. I wonder what the prior is here. Distribution prior is an uncertain quality. Sure. Which doesn't change. I was wondering if it learns. So in general, I don't think it actually matters. So let's just make a choice, right? So I want to get a working prototype as quick as I can, because I already spent a lot of hours trying to really understand what all these things mean. But at the same time, at some point, I think it's important that you're kind of willing to say, okay, this is it. This is gonna be it. Instead of, I think it's from Basecamp. There's a very big startup or company right now, which has written a book, Basecamp book. It's about like managing your work week. It doesn't have to be crazy at work. And what they say in that book is that as you go along, and you should never expand when you're working on a project. So you should always start from the broadest idea you have, and then as time passes by, you need to cut stuff off. You want to make it like you want to go smaller every time, because time keeps running out, right? So you cannot say, okay, and we need to do this, and we want to do this, and we got to do this. No, you have to like become more and more specific as time goes by. So that's what we're going to do here as well. So knowing one thing is not the same as being able to apply it. So we are just going to make a choice here, and we are going to follow this guy's advice, and we are going to make the choice of setting PZZ to be uniform 1 1 minus 1 1. I honestly don't think it matters that much, because the generator, so the generator learns, like, it maps a function, right? So it maps a function of the noise to fake images, and that function is going to become better and better. And so whether it is -1 or 1, I don't think it could be as well -2, right? And then the scaling would be different. I might have chosen like maybe a Gaussian distribution. Some other ideas I had was using the training data to kind of, because the training data is the training data we have is a 28 by 28 training data is 28 times 28 times 1. So what I thought, maybe for every pixel, so for every pixel you could maybe average or estimate the mean of the grayscale value of each pixel, and then get like a 28 by 28 times Gaussian distributions. Because for example, the top leftmost pixel might always be white or might always be black. And in such way you might always want to generate white there in the first place, right? So the generator doesn't have to learn anything. But that is an idea for later. So an idea for later is that we can put the prior to like averaging out the grayscale pixel grayscale values. I think that is mentioned somewhere in the original paper. So let's Google prior here. So we define a prior, and then here we do prior. Okay, so it doesn't mention anywhere what they're doing with the prior. Yeah, so that is one thing I didn't like about the paper. The paper is in general very clear, but it's very light on details. So it's a lot of stuff that is unspecified. So like there's no mention of the amount of hidden layers. There's no mention of what prior they're using. I mean, I think I saw the word uniform once, but that is only for this example where they give like a like an intuitive example of what of the GAN, right? So we have made the choice. Z is just simply uniform. Top priority, step 1. Figure out how to specify the prior. Sure. Can we mark this as done? Can we mark this as done? Not yet, because we have to generate that, right? So what is the input of the random noise? Let's see. So 28 by 28. Let's think about that. Because so we input random noise. Let's call that Z. So here we load. Okay, I'm just gonna kind of clean this up here. So this is training data, fake data. All right, here we're loading in the data. Free up some space. We can create some nice plots. Sure. You can check for missing and null values. We did that. Then we normalize the data to make it more easily trainable, right? Then we reshape them and turn them in a 1D vector. No, we loaded them into a data frame, which turns it, turning it into a 1D vector, sure. Then we one-hot encode the Y labels. So this is for the training data. Why do we do this? Good question. I honestly don't think we need the labels. Yeah, so one thing that annoyed me, or if any of my viewers, if you guys are seriously watching this, I don't know what is going to happen with the labels. Like, I don't understand what is going to happen with the 0, 1, 2, 3, 4, 5. Because maybe my brain is not working properly, but what I keep running into is, so you generate fake data. So you're gonna generate a 784. You're gonna generate from noise. You're gonna generate 784 pixels, 784 numbers between 0 and 1. If you stack them, that's gonna be your fake image. Hopefully, the fake image is gonna be very close to the real image after training. So these are just X values, right? The discriminator takes in X values as well. So that takes in training data and fake images. Now my problem here is that the discriminator just takes in images, right? It takes in X values, which we wrote down here. The discriminator takes in values of X. Can I select some text here? It takes in values of X, right? And this parameter. Hey, Sir Nightlord, thank you so much for following. I appreciate the love, appreciate the support. Yeah, good morning or good evening or good afternoon. Um, so yeah, so my kind of issue here, the one thing that I don't really grok or understand yet is the fact that I don't see where we use the labels anymore. Maybe it's in the loss function, which we haven't got into programming yet. Because what I see here is that so we input noise in the generator, so we just input noise, and the generator spits out a fake image, right? Then this is just all x's. This is all x's, and we are gonna put the x's that we either generated or from the real training data. We're gonna put the x's in the discriminator. So the discriminator is a simple neural network that takes in images and is parameterized by this parameter vector, sure, and then spits out a number that indicates the probability that the image is indeed real. So it spits out a number of the probability being real. But then, like, where do we use the label? Like, where do we use the fact that it's either that we want to generate a 0 or a 1 or whatever, right? So that is the one thing I'm missing here. So maybe I should write that down here in my notes as well. So questions. I still don't understand what is happening with the one hot encoded label. Maybe they can't show up in the loss function or backprop alg later on, but right now, no clue. Okay, so good morning for my new viewers or new viewer, I don't know. Today, in this quick session, because I have to go in like 4 or 5 hours, depending on whether you think that's a quick session, I want to build a GANs. So we spent a lot of hours already about GANs, writing about GANs, probably understanding what they are. Today we're going to finally freaking build a GAN because I'm sick of it. I'm going to open my Superwork document, which is my productivity tool. So if any one of you knows Ultra Working, it's kind of like a simplified version of the UltraWork spreadsheet. It's very easy and it keeps me focused a lot. It's just a simple Excel sheet where you where you fill in what you want to do, then what you did, and finally what you have done during the workday. It keeps me very focused because I'm easily distracted and I often get sidetracked very quickly. So this thing kind of keeps me on my toes here, and of course you guys as well. So I'm gonna, if my internet decides to cooperate, I am going to quit Photoshop. So we made this image, I think in the second stream or the third stream. The image seems very convoluted if you look at it from this standpoint, but during the stream we built up the image very slowly, and every time we went over, every time we added like something new, we went over it again with a different color. So we kind of went over the whole process of the GAN multiple times, which was really nice. Yeah, so then we also wrote a, so yeah, okay, sure. This is stream 5 actually, stream 5, and today it is the 17th of November 2018. So I didn't make a Superwork file for stream 4 because that was yesterday evening, and yesterday evening we made this. So we took 2 hours and we wrote a bit about GANs because, of course, so I do the programming GAN for you guys, but it might be nice to have something in the end to look at, like just to have a quick document of what we did. And I think it's also nice for myself, so I can read it back like maybe a year from now on or 2 years. And I remember, oh yeah, we did this, etc., etc. So we went through the original paper. We started with a general explanation of what a GAN is. Then we went over all the symbols in the paper, which we dissect here. Wait, sorry. Which we dissect here. It's this one, I think. Yeah, so we did go through the original paper. There are a lot of symbols over here. So we kind of took all the ingredients from the original paper and we tried to dissect them one by one to get like a real overview of what a GAN is. It turned out it's not that difficult to understand, but the program one is difficult. So what am I trying to accomplish? Program a GAN. Why is this valuable and important? Well, because machine learning is awesome, but at the same time I want to move on to new hello? Okay, so my computer is kind of freezing. Hello. So, okay, I'm gonna just think about, so because machine learning is awesome, but at the same time I want to move on to new stuff, right? So I have a lot of ideas for future streams. I don't want to say I'm passionate. Okay, I am passionate, but I want to visualize neural networks. I think seeing graphically how a neural network is able to train itself, how the weights shift from being random to like kind of converging to something, I think that would be a very interesting project to see visually how the model trains, right? So that's one idea I had. Then I have this second idea, any social links, Sir Nightlord. Sir Nightlord asked, any social links? Thanks for asking, that's a very good question. I'm embarrassed to say no, but I don't have any social links right now. So what do you want to see? You want to see my YouTube? My Facebook? Because I'm kind of new to the whole streaming thing. And I don't want to bother people with spamming my Facebook and everywhere. I can upload. Should I make a Twitter? Maybe I should make a Twitter, right? Where I can post, hey guys, I'm online and you guys can follow me. Would that be useful? I kind of don't want to be a bother to other people on social media, but yeah, I think I'll. Okay, good suggestion, Sir Nightlord. Thanks for following. I really appreciate it. It means a lot to me. Like it honestly means a lot to me because it kind of gives me feedback. It kind of gives me feedback that I'm doing something right. Okay, okay. So I will put that. I will make that a top priority as well. Make a Twitter. Make a Twitter for Sir Nightlord. Or at least like make like social links, right? Maybe Facebook, Instagram, Twitter. I'll make it separate from my kind of real. I'll make it separate from my kind of real life, I guess. Maybe not my YouTube. You can go to my YouTube. You're just creating magic. Yeah, don't mind the username. It's really lame. Like when I was younger, I don't know, like 11 or 10, I was really into. Oh wait, I opened it on my wrong screen. So when I was younger, I was really into magic. So maybe I should try and change the name here. Okay, I will. I'll make a Twitter. I'll make a Facebook. I'll make an Instagram, and then I'll make a new panel. I also try to get a schedule up for when I can stream because I think it's nice if you guys have some heads up, right, when I'm gonna stream. So, Sir Nightlord, what time zone are you in? Like what time can I accommodate for you such that you can watch me? Because I've had viewers from both the U.S., also from Asia, like India, but also a lot from Germany and Sweden. So I'm kind of on the fence of when I want to stream, because I like streaming early in the morning because then I'm at my sharpest. But I don't know. I might have to make a compromise here. Okay, so if you could answer that, it would be awesome. Like what time suits you at least? So why is this valuable and important? Because machine learning is awesome. At the same time, I want to move on to new ideas, such as style transfer, deep neural networks, visualizing how neural networks train. I had some other really cool ideas. I was in the shower. Oh, I want to do some computer vision. I had this idea of doing like IMDb screen time is an idea that I had. So the idea there is to get a load of films, like get like I don't know, like a lot of films with Nicolas Cage in there, or Tom Hanks, I don't know. And then we would scrape the actor list from IMDb. So we would scrape all the actors, and that would give a list of names. Then we would do a computer vision algorithm on every frame of the movie, and we would try to extract all the faces from that, right? But we don't explicitly say which face is which actor. What we then want to do is we want to find like 100 films, all with Nicolas Cage. And then the idea that I had, I don't know how I'm going to do it, but that's a high level idea, is that we are able to cross-reference kind of the same features that Nicolas Cage has in 100 movies, right? And then try to see if we can figure out who Nicolas Cage is, what is his face, because we have so many different movies of him, without explicitly saying this face is Nicolas Cage. That is an idea I had, which I'm very eager to program in. But then again, these streams kind of have learned that there are more ideas than time. So ideas pop up quicker than I can program them in. So Sir Nightlord asks, what is the best way to get into machine learning? Well, of course, the best way to get into machine learning is watching my stream. No, in all honesty, I think that so you need a very, I don't want to say you need a strong math basis, but it's nice to have a solid grasp of linear algebra and calculus. By any means necessary, it's not, you don't need like a very deep basis in statistics. People think that, like, I keep repeating that machine learning is kind of beefed up statistics, which is true, it's very hyped up statistics, but at the same time, I've had very, very, very deep statistics because I studied kind of like applied math with a focus on like financial math, which is basically all statistics. But so you need, okay, I'm gonna be honest, you need to know linear algebra. You need to know matrices. You need to be well versed in being able to manipulate matrices. And like, that is in general, I mean, you don't really need it, but it simplifies the math a lot. I could maybe do like, I maybe could do a stream where I build a neural network with just no linear algebra at all. It will be inefficient, it will take longer, but it's very possible. Linear algebra is just a tool to kind of vectorize everything, which allows optimization and easier stuff. So getting to machine learning, I suggest just getting like getting hyped up about it, getting passionate about it, and then reading some fun tutorials, I guess. Because I think that the only way to get into machine learning is to actually do it, right? So try to open Python, try to learn Python, try to program in a neural network. That is what we did in the very, very, very first stream, right? So I don't know if you tuned in. I don't think I saw you. In our very first stream, which was a couple of days ago, I only started recently. You can watch it back on my Twitch page. I'm gonna download it and put it on YouTube as well. So we our very first project was a neural network. Which we have here, and here so I mean, that is what I'm doing right now, right? I'm getting into machine learning, so to speak. So here we have a neural network which we built in the first stream. It's actually more comments than it's kind of more comments than code. And here we have 4 observations. So the algorithm is very stupid. It trains on 4 observations, and it has 4 labels. But then we build the neural network. We say, okay, we want a neural network. Then we train the neural network. So then we train the neural network. Here we instantiate it. And that's it. So, hey man, this is my first time tuning into your channel. Don't worry. If you have any questions about GANs, because we're gonna program in the GAN now, the Generative Adversarial Network. And we already spent quite some hours trying to deeply understand what GANs are. So because we did that, we have a very both high-level overview of what a GAN is. So what is it at a high level? But at the same time, we have the ideas of the equations that are underlying the GAN algorithm. So like honestly, if there's anything that you don't understand, like I'm really honest here. If there's anything you don't understand, feel free to ask it in chat. I will answer you, and I'm really happy to answer all your questions. Like, don't think there are any stupid questions, because so I'm a math tutor. Well, I'm technically not a math tutor anymore, but I've taught like math all my life, and the worst thing, well, not the worst thing, but a very difficult thing about tutoring is asking someone like, "Do you understand this?" And then they say yes, or they nod their head, but you know they don't understand it. So, um, a very funny story. Um, I've tutored like hundreds of, okay, that's maybe a bit excessive. I've tutored, I think, like 20 different kids, but there was this one girl and she had autism, like Asperger's syndrome. Um, and actually she was my favorite student because she was like brutally honest with me. She was like brutally honest, and it was so nice because it was so refreshing. Because if I explained something and I asked her, "Do you understand it?" she just said straight up no. Like every time she did not understand it, she said no. And I mean, maybe that happened 30 times in a row, and I would try to explain it 30 times differently in a row, and she kept saying, "No, I don't understand it." And to me, so to the normal person, that might seem like she's wasting my time, but I felt the complete opposite. I felt like she didn't waste my time at all, because I mean, she's paying me for it, right? I'm providing her with a service, and it's in her interest to kind of get the best possible explanation from me. So what I want from you guys is to kind of try and be as autistic as she is, and if there's something you really don't understand, if there's something that is still vague, even if slightly a bit, just ask it in chat. I mean, if I'm mad at you, I'll just ignore you, right? But if I think, yeah, that's a good point, I'm really happy to explain everything. Um, so I mean, if it's about the general idea of a GAN, if it's about the low level equations, I'm really glad to have you guys here and willing to explain everything all over again. Why? Well, because I'm a teacher and I have endless patience. So really, don't worry about stupid questions. Um, I believe that there are no stupid questions. There are only stupid answers, right? So if you ask a question and I get mad, that's on me. That's not on you. Because if you don't understand something, you have to tell me, and I will explain it again. Okay, so enough ranting about me, because I can rant a lot. So I had one new follower, Sir Nightlord. Thank you so much. Hey, Jon Kime. I've seen you before, I think, right? But I don't see you in my follower list. So if you want to get a heads up for when I stream, you should follow me. 8 a.m. streaming, and I thought I was early waking up at 10. Yeah, I know, right? Omega lul. Uh, yeah, so yesterday evening I streamed at 10. So I graduated yesterday, like I officially graduated yesterday. Um, and I was really kind of tired, but at the same time I wanted to put another stream in. So yesterday evening at 10, or from 8 to 10, I believe, or from 9 to 10, I wrote this small document here, which is kind of an introductory document about GANs, both at the high level and the low level again. But this morning, I already been streaming for half an hour. This morning, I really want to program in the GAN, because we spent already a lot of hours, a lot of time understanding it. But this stream is not about, okay, it is about understanding what a GAN is, right? But in all honesty, I want to program in the GAN, because that is what I like. I like programming. So how will I know this is complete? What am I trying to accomplish? We want to program a GAN. Why do we want to program this? Because, well, it's cool, but at the same time, I want to move on. That's basically my main reason. So how will I know if this is complete? When is the GAN complete? If we can generate new fake images. So if we can generate new fake images. Hopefully they look like real numbers, but that doesn't necessarily, but that probably won't happen. So what I predict that will happen is that our GAN will predict like huge blobs of white or huge blobs of black. It won't resemble anything like numbers, but I mean that's basically fine-tuning the algorithm, playing with the different activation functions. So Yankime says, or how do you pronounce it? YWN Yonklim. Okay. I'm keeping my follow list clean so I watch a stream 1 or 2 times before clicking the button. So I won't need to unfollow a lot of streams later. Yeah, good. That's a good thing to have. That's a very smart thing. I barely follow any streams as well. What streams do I follow? I don't know. It doesn't matter. Okay, any risks, potential hazard distractions. So I'm on a time limit here because I have to go at roughly 12 or 13 for some personal stuff. Of course, the internet. Internet is a distraction. Phone. Twitch chat is a bit of a distraction, but it's a good one. Maybe I have some tea breaks, some bathroom breaks. That's basically everything I can think of right now. Young Kimi asks, what did you major in? The Vim editor is already starting to give me the day nightmares about my time in computer science at uni. No, man, I love Vim. So I majored in econometrics. So I'm from the Netherlands, and we have this thing here called econometrics. Personally, I hate economics. Well, okay, hate is a strong word. I don't hate anything. I'm not really passionate about economics. I studied econometrics, so I'm going to write that down for you guys here. Econometrics. And I think that the Netherlands and the UK are the only 2 countries in the world that provide a graduate and undergraduate education in econometrics. So basically what we learned was applied math. So we learned applied math. So I have formal training to become a quant or like an algo trader, right? But also to become like a financial analyst or whatever insurance guy. So we have a lot of difficult math. It's admittedly not as rigorous as a pure math degree because I did take pure math courses and they were significantly more rigorous, which I did like. Sometimes, so like, I think that pure math is sometimes just a lot of mental masturbation because I think that math is a tool, but then again, you can go real deep. So pure math is very solid. It's very watertight, right? You cannot put, if done correctly, you cannot find any weak link in there. But at the same time, that makes it very difficult for people to get into. Then we have kind of the like slight level higher is what we do here. We do applied math for financial econometrics, insurance, etc., etc. I like that a lot, but I don't want to say. I mean, my passion. I think machine learning is really cool. AI, artificial intelligence. So that is what I'm trying to look for in jobs. So I'm kind of being trained in these kind of like quant, algo trader, data scientist. And right now, you see that because of the AI hype, our econometrics applied math a degree is keeps changing, evolving, and taking on machine learning because the university thinks that is the direction that the world is going to go in. And I tend to agree, but at the same time, I don't think that it's the university's job to follow the hype train, right? I personally think that the university should be like this pristine organization that values truth and learning, and I don't think that job demand should factor in that. But hey, nothing is perfect, right? So that's my personal opinion. Don't take any word from that. What did you major in? Vim. No, Vim is great, man. I started using Vim 4 years ago. Maybe I can find it on. I posted it on Facebook once, and so every year now I get like, you posted this on Facebook, and then I see that I have like GVim open on my Windows. So yeah, Vim takes such a long time to get proficient in, but in all honesty, it's totally worth it. Like I can do this, I can remove it, I can put it back, I don't know, go up to like, say I want to go up to the top priorities line, right? And then boom, I'm there. So if I want to go back to the line with econometrics, boom, I'm there. It takes a very long time to become proficient in, but once you get it, it just clicks, and you get this whole different perspective of what text is and how you can edit it, right? I love it. I'm trying to dabble in Emacs because I think Emacs's org mode is really cool. So I'm not a fan of both. I use Vim, but I'm not that kind of a religious nut in terms that I despise org, because I think both have very good properties. Vim plus LaTeX is some science shit. Yeah, you can write real fast LaTeX with Vim, right? If we open a new pane here, and we don't have LaTeX nodes here, but in the here we have LaTeX nodes. So let's see if we go to, I think, text. No. Oh no, it's we have a book here. CDML book. We're gonna write a book. Well, not gonna write a book, but we're gonna write some text, right? So, or maybe I have it open here already. No, I don't have it open. So Vim is great because, like, especially for writing LaTeX. So okay, I'm a huge nerd. I kind of hope you guys are all big nerds as well. So when I do things like 37 times, I think 37 is a nice number, or 7 times, depends on how often you have to do them. So for example, if you have to write begin, align, asterisk, enter, and then you have to write begin and align, and you have to write like freaking 25 papers for school, right? You're gonna look for ways to kind of automate that. So you make like a binding, like boom, and then you can type blah 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 equations, and then you jump out, and then you jump out again, right? Or like if you backtick alpha, backtick plus a expands to alpha in Vim. Like I can now type backtick a and it expands to alpha. Like these things they save me a lot of time. People always look at me in class. Like if someone is writing, like I don't have class anymore, but when I had class, I was able to write LaTeX at the speed that some math professor was writing math on the board. And that both impresses people, but that's not the point. The point is that you have very clean notes that you can that you can revise and then reread them later on, right? That's the whole point. It's clean, it's nice, it's easily editable. So yeah, let's kill this pane. Let's get a matrix. Does it work? C matrix? Yeah, that works. So this is just to keep your attention here. Wait a second. Young Kima says, no, I'm not saying anything against personal choices. I know that most professionals use good editors, advanced keyboard layouts. Not for me. I dropped out of uni 3 years ago because of physics, math, and comp sci to become a designer. Wow, that is both awesome and very scary, right? You became a designer. What kind of designer? Like a UX designer or like a graphic designer? I mean, yeah, so I kind of don't like that you need a university degree, so I have one, right? But at the same time, I don't think, I'm kind of on the fence about, it's a signal for employers, right? It kind of sucks, but if you have a degree, then an employer immediately knows kind of that you have some certain base level of things you are supposed to be able to do. And especially, I like, right now, getting a job somewhere entails being able to convince someone to take a gamble on you, right? But I'm very scared kind of going into a minority report situation where getting a job is not based on convincing a person, but convincing an algorithm. And I think that's a very scary thing because, so my personal view is that, oh man, I love this Twitch. I have so many ideas. I have so many personal views I want to share with the world, but no one wants to listen to me because I sound like a crazy tech guy, right? So my personal view is that once AI job applications are becoming real and like the standard, I think it's gonna be very rough for a lot of people, because if you have like a lot of people with great degrees and they come into great jobs, that retrains the algorithm to think, we are going to hire someone with a degree more often than someone without a degree, right? And the problem with this is that if there's a system, my view is that if there's a system, you can game it. If there's a lock, you can pick it. The most trivial example is that the algorithm that picks a lock is the key, right? But that doesn't necessarily mean that is the only key that works. So if there's a system, if there is something that you know that is being optimized, you can't simply exploit it. I don't know if there's a name for this. If there's a name for it, please let me know. Like, I know that there's Arrow's law, not Arrow's law for the man, but I think I think it's like if you have a measure and you use that measure as success. No, this is economics. Maybe it's if you look like a measure of success, bad measure. Probably got that. True measure of success, measure of success. No, 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 no. Okay, so if you use a measure, then it becomes a bad measure. There is a name for this. Come on, what's the name for this? There is arrow measure. Arrowpred measure. No, 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 no. Success bad measure. So the idea is that if you have a target, oh man. So if you have a goal and use that goal as a measure of success, it becomes meaningless. Now Google, come on, help me out here. Goodhart's law. Thank you so much, Google. I just look Goodhart's law. I was not even close. Arrow is not even close, but it's Goodhart's law. So more UX though. I don't like it when people invent new cool names for professions. It was a designer, not a UI, UX interaction architect. There was a Hey, Jan Klime, thank you so much for following. I really appreciate the support. It helps me a lot. I have a follower goal of 50, so I can finally start monetizing my channel. I feel like that's kind of scummy that I'm saying that, but at the same time, I won't plug anything that I don't believe 150% in. So if you have friends that are interested in this kind of content, so the idea that I'm having right now is that I want to plug books on Amazon that I truly, truly, truly believe in, such as Learning How to Learn, Deep Work by Cal Newport, and other like books that I deem so interesting that I'm willing to plug them. So if you have any questions about interesting books to read, wait till I have 50 viewers, and then you can support me. Young Kima says, there was a guy in my group at uni who wrote notes in LaTeX so good. A professor asked him to send a copy. He reviewed it, and we all got something like a book at the end we all can use. That was awesome. This was in functional analysis for quantum dynamics. Yeah, quantum mechanics, sorry. Quantum mechanics is something that I think is really cool. I'd love to read and understand more about it, but I mean, as I said before, right, there's not enough time to do everything. And the focus of this stream is machine learning, but maybe there is some room for quantum machine learning if I can understand what that is. So maybe I will make time for that, because this stream is about starting from scratch, right? I'm not gonna assume that you guys have any prior knowledge except for some university level background in math. So where was I? This little Googling thing, Young Kima says, this little Googling thing got you a follower. Reminded me of to find a nerd thing I heard of, but I don't remember. Just sounds smart. Yeah, I think that Googling is a very important skill to have, right? I think especially when you're a programmer, there's so much high quality information available on the net that that being able to Google your error in such a way that you get an answer that's in such a way that you might find something that someone else already did is, I think, a crucial life skill for a programmer, because I mean, I don't know everything. I think I Googled a min-max game. I think during the stream on GANs, I Googled what a min-max game was. I've had extensive courses in game theory, right? I studied econometrics, which is part economics. So I had extensive courses in game theory, but I simply forgot what a min-max game was. So then you just Google it, right? Okay, so where was I? I was at Goodhart's law, which says that any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. So what this basically says is that if you have a metric and you put pressure on it, it becomes a bad metric. If you measure the success of a country by GDP, companies will exploit that and find ways to maximize GDP. If you put pressure on something and you value high grades, people will find ways to game the system and get high grades. Science, or at least one scientific study, has shown that people that are the most ambitious are the most likely to cheat, especially in China, where there's so much pressure upon them, there's so much pressure to get high grades that people will do anything to succeed. Similarly, why I came to this was, if there's a system that values degrees, right? If we have AI job applications, which is already happening in Amazon, right? In like the big companies that need to have some kind of streamlined funnel process, and if you don't have any human intervention, then it might collapse to an equilibrium or a training weight set that just puts a lot of emphasis on degrees, and I think that's very scary because there are some really cool people that, I mean, Bill Gates dropped out, Steve Jobs dropped out. I don't want to say because they dropped out they became successful. It's probably the other way around. They had something going for them. They took a huge gamble, then they dropped out, and it worked out for them. Of course, there's this selection bias because there are people that had successful startups, dropped out, and we don't hear anything from them. So we got to keep that in the back of our mind. But yeah, so my point still stands. Jan Klime says, I think that knowing these little things and examples makes you a good thinker in general and easier to explain things. And that's really useful from design work to arguing with your partner what to prepare from dinner. That's why YouTube algorithms are secret because of this law. Yeah. That is true, right? That is indeed true. Yeah, the YouTube algorithm is brutal. Like, it's really brutal. But you see that people are trying, like, I think this is a really cool, so we're getting sidetracked a bit, but I think it's really cool to think about. So I watch PewDiePie, so I think he's a fun guy to watch. I think I started watching him when he did his kind of videos where he got scared, where he played horror games. I thought they were very entertaining to watch. So basically, all the YouTubers found out that if you publish content every day, your algorithm will you will appear more in the related videos, right? So this put like enormous. So people are trying to kind of backwards engineer the YouTube algorithm, right? And I think this is kind of like even if it's not explicitly mentioned that the algorithm emphasizes that people observe this pattern. People that upload a lot get a lot of views, get a lot of ad revenue, right? So this puts enormous pressure on YouTubers to provide content daily. I think Casey Neistat is also a very popular vlogger, and he got his breakthrough the moment he started vlogging daily. He vlogged daily for 2 years. That is an insanely long, well, 2 years is not long, but if you have to make a vlog every single day, that puts enormous pressure on someone to produce content, right? So people have found out that like there's a recency bias or like a novelty bias in the algorithms. I don't want to say bias, but so there's a premium for producing new content, and this of course is like YouTube is like, I think it's crazy, right? Because YouTube is like a company. It's like it's Google property. We have to keep that in the back of our minds. Like sometimes we think that YouTube is like, I don't know, it belongs to the world like any government does or something. No, it's a company. It's a company. It thrives on content. I think it makes a loss. I think it makes like billions in years of losses, like YouTube revenue or profit. I think it's highly subsidized by the ad revenue of Google, right? Where are you getting hard data that YouTube isn't profitable? Sorry, I'm just gonna catch my breath here because I've been talking for an hour straight. Ad-supported revenue is a juggernaut. So ads, right? Is it profitable? It never discloses it. There's substantial uncertainty. YouTube scale, they're reasonably profitable. That's a guess, right? My guess. So in all honesty, like YouTube is a company, but it is so ingrained in the social fabric. I mean, just imagine that YouTube would go down. Like, where would you watch videos? Vimeo? No, you only get like hipster artsy videos there. Dailymotion? No, that's only crappy other videos from YouTube, right? So YouTube has the monopoly on internet video, and that is huge. It is so huge. Just like Google has the monopoly on internet search, right? And Amazon and Alibaba have like a duopoly on kind of and so there, like, I'm a fan of capitalism, but at the same time I think it has a lot of bad things going for it. Um, but I think at its essence, capitalism is a good thing where the essence is that you try to make something that is of value to someone else. Then you trade that thing, which creates kind of a surplus, which you can share in some particular way. That is the key essence of capitalism, in my opinion. But it does. I mean, we like it. Like, how far do you have to? Fuck you, Tang. What? Fuck you, Tang. Okay. Good morning, Sudoku underscore. Thank you for joining me today. I know an Asian guy in class. Um, his last name Tang. Fuck you, Tang. Is that Sir Nightlord? I don't want to expose anyone here, but Sir Nightlord was here in the morning. I don't think if he's still tuned in, but if you guys are watching me, thank you for tuning in today. His last name Tang. Okay, good morning. Sorry. Jan Clemens says, my general pattern of arguing, get my general ideas in words, find the science abstract thing for it, add an easy, well-known example. By that point, they just want to shut up and agree with me. To be honest, I would watch movies or series, Netflix. Yeah. Can you machine learn me? Oh, wait. You want to kill me. You want to kill... Oh my god, I feel so stupid right now. Sorry. You want to kill me. Yeah, of course. Oh, good morning. Yeah, it's a wake and code session, right? So, I've... yes, Sudoku, I will machine learn you. If you stay tuned, if you hit me up with a follow, we will get back into machine learning. We got sidetracked for, I don't know, like 10 minutes talking about general philosophy stuff. Yeah, so you will kill me. I think that there is, I think that arguing with someone in general should be avoided. So there's okay. So there are two kinds of arguing, right? You have a debate where you're on a stand. Would you rather talk of STEM? I'm fine doing both, but the goal of this stream is to get you guys up and running into machine learning, building our own algorithms, showing how they work from the ground up. Don't call yourself stupid. Not a single person got the full name. You will not. You will kill me, or you will not kill me. You wanna kill me. You wanna. Yeah, maybe if you had like, you wanna kill me. Hey Sudoku, thank you for the follow. Sudoku underscore, highly appreciated. Okay, so last thing I'm gonna talk about arguing. Then I'm gonna get back into GANs. So I think that you should basically never argue. You should you cannot convince. Who cares? I like this guy. He's so straightforward. You cannot convince someone that doesn't want to be convinced, right? It's the same with the Democrats and the Republicans. Both of them have different viewpoints. Both of them have views that are right in their eyes, and screaming at each other won't help. Because if you don't want to be convinced, then you will not be convinced. It doesn't matter how much facts, how much logic is thrown at you. If you're not willing or open to change your mind, then you will never ever... I mean, that is why it's useful to start off any debate with, okay, at what point, like what evidence do we have to show to you that you are willing to change your mind? If you have that down, you have a goal, you have something you can argue towards. Otherwise, the other person can always move the goalpost in saying like, well, I don't care. So, right? So always try to avoid arguing. Always try to be respectful of someone else's ideas, even if they are wrong, right? I used to be very bad in this. So I used to value being right a lot. I think we all value being right. especially if you're into STEM and math and stuff, you sometimes value being right more than, I don't know, being nice to someone or something. Um, but being right can kind of hurt someone's feelings. And the point is, you can be right without being a dick. So you can say, you can say, no, you're wrong. You can say that to someone in a very harsh tone. What you could also say is, okay, you make some good points, but I think that we should focus on this. Or I think my personal opinion is that this weighs more heavily, right? Um, so in general, you want to avoid arguing. You want to sidestep any argument, because if you're arguing, you're like two goats trying to ram their heads into each other. What you want to do is you want to turn the other goat around and look in the same direction. You have to you have to make the point where instead of arguing, you're both looking for a solution that is beneficial to both of you. And arguing often kind of does not mix with that goal of trying to find common ground, a common solution where you can both benefit. So we had some chat in here. Welcome, new viewers. Yeah, so sorry, we are talking a bit about arguing and philosophy here instead of machine learning, but we are gonna get back into machine learning right now. Let me see. So don't call yourself stupid. Who cares? Let's me it happen, sir. Can you depart some knowledge because I made it on purpose? Okay. The average man doesn't look twice. I would remake name. Everyone remembers me. I'm a fairly intelligent man. I thought your name looked like Mumbo Jumbo. I don't need to hear what arguing is about. Do you have any knowledge? No, we're not. You were talking about arguing. Yeah, thank you for the comments, Sudoku. We will get back into machine learning. Thank you for keeping me on track here, because that is what this is about, right? So no new window, sure. Yeah, so we have Vim open here. We have the main file open here. Yeah, so let's get back into GANs. I have some new viewers. If you have any questions about GANs, please ask them in the chat. I'll be happy to answer any of your questions. It doesn't matter how high level or low level. But as of right now, we have to make 3 decisions. We have to figure out how to generate random noise, program that in. Then we have to figure out the discriminator. The generator, we have to make fake data from that. That's step 2. Then in step 3, we have to make the discriminator, where we take in images and we produce a number that is fake or real. I have questions, I'd be happy to ask. All right, you can ask them in the chat, Sudoku. I'm happy to answer. So we already did the first thing. So we have a checklist here. Let's make a checklist. So number one, we have to decide on the noise prior, right? And we did that because the answer is that we're going to make it uniform between 0 and -1 and 1. Sudoku asks, make noise. Yes, so in the first step of the algorithm, you have to generate random noise. And if we look at the schematics, so here we generate random noise, and we do this based on some prior distribution. We generate noise according to some distribution that we name PZZ. PZZ is something that we have to choose. Sudoku asks, do we have to normalize this noise? The answer is no. I don't think we have to normalize the noise. We might, but I don't think we have to, because we are able to choose the distribution, right? I saw you pick the distribution between -1 and 1. Yes, I did. Why? Because someone else did it, and we have to make a choice at some point. You can always debate about choices, but at some point you have to make a choice, and you can always change it later on. So, let's generate some data, right? So yeah, checklist. Decide on noise prior. Sure. Now let's generate some data. All right. Let's see if this still works. Let's see if we didn't break anything. All right, so as you can see, we pick a distribution randomly. Not necessarily randomly. Yeah, like you can view it that way. A normal distribution, no, we are choosing a uniform distribution. I have debated whether to use a normal distribution, but we are not going to use a normal distribution. We're going to use a uniform distribution. Why are we going to use a uniform distribution? Because this other guy, only NumPy, because we had this tutorial and he got relatively good results and he used a uniform distribution between -1 and 1. So that is literally the only reason we are going to use a uniform distribution. I had another idea, like, so every image here, right? Every image is a 28 by 28 pixel value. So why are we using uniform? Because this guy is using it. I mean, we could have used any other distribution, but uniform seems like a nice compromise. So, okay, we got an error here because we cannot import TensorFlow. I spent a half of the second stream debugging my TensorFlow with the chat, and it turned out that we have to make like a virtual environment. So we have to activate our virtual environment again. I think it goes with source, and then venv bin activate. And now we are back in the virtual environment. I'm going to copy this real quick and I'm going to paste it because so to activate virtual end. So in general, what I'm doing now is very, very, very bad practice, right? You don't want to write your comments in your Python code at all. But I mean, this is a stream and I want to show you guys the whole process. So I think I'll leave these comments here. I won't even remove them, maybe for later versions. Sudoku asks, could we use a Poisson distribution, maybe binomial? Yes, I think we could use all of them. Because like, I would literally show you the distribution. Have you tried testing the date on a stat plot? Could you explain what you mean with testing the date on a stat plot? Because I don't understand what you mean with that. It would literally show you the distribution. The date on a stat plot. Testing the data on a stat plot. I don't understand that either. You mean, I think I understand what you mean. Like, you want me to make a histogram? Or like kind of, maybe heat map or something, right? Of the data. And then you can make maybe a 2D Gaussian distribution. Is that what you mean? I'm gonna have to take a quick break soon, by the way. I think I'm gonna take a quick break now because I've been sitting here for an hour, and sitting too long is bad for your back. So thank you so much for tuning in, all my 4 viewers. I hope I am and will be able to learn you something. And hopefully you guys have the patience to just put my stream in the background and keep the noise on, or maybe keep it muted. And then join in with me 5 minutes or 10 minutes from now. I'm gonna get a new coffee. And I'm gonna take a quick break of 5 to 10 minutes. So what we did, or what the plan for this session is, oh shit, I should have put that in here because we already spent, okay, I'm just gonna put the final date is 9 exactly. The one thing I want to accomplish, okay, we didn't do all these, but did we complete the cycle target? Sure, we did it half. What did we do? We chatted in chat a lot with Sudoku, with you will not kill me. And Sudoku underscore. We chatted about general stuff like schooling, arguing, GANs, and answering lots of questions. What we did, we decided on the noise distribution. That is good and important. So things to improve next cycle. Nah, it's all fine. So what do I want to do here? I want to do two things. The first thing I want to do is generate noise. So my vision, my idea is that in the next session, you have to have a goal that is so small that you can achieve it. If you achieve a goal, that means that you're motivated to do more, etc., etc. So I want to generate noise. This is literally just one line in Python. Then if I am to finish this, I want to try and see if I can get the generator working for random weights to generate fake data. So get the generator working. So what does this mean? We have to instantiate a neural network, and we have to be able to feed in the random noise and propagate it using feed forward. This is already way more ambitious because we have to rewrite the feed forward algorithm and the loss function, because we used the squared error loss during programming our neural network, and right now we are using a very, very, very different loss. So what distractions are there? We have the internet, we have my phone, we have Reddit, we have social media, we have Twitch chat. All right, so that's for next session. I have a lot of questions here from Sudoku. Sudoku asks, what data analysis methods do you use? Software, Minitab, Excel. I don't know what Minitab is, actually. I use Python and Pandas. I am very well versed in MATLAB as well. A Minitab, what is that? This kind of looks like stuff you can do in MATLAB, right? Yeah, I use MATLAB. I use Python. Pandas, usually. Pandas, NumPy, SciPy, all that good stuff. So yeah. Okay, hopefully you guys can see this here. Brick. No, brick small. All right, thank you so much, Sudoku, for seeing the progress. I'm happy to have you guys. I'm happy to have you other viewers as well. I hope you guys have the patience to wait 5 minutes or 10 minutes such that I can stretch my legs, get a quick break in, and generate some coffee. Get some coffee. Because I literally just rolled out of bed, put on my bathrobe, got a coffee, and then started this stream. So I hope you guys are willing to take a quick break with me, maybe stretch your leg yourself, get some coffee, and I will be back in 5 to 10 minutes. All right, hopefully I'll see you guys then. Okay, I'm back. Okay, I dropped some viewers, but that's to be expected, right? I can't expect anyone to have more than 5 minutes of patience. I fully understand that. I like that Sudoku is saying, "What the fuck, man? How do you dare take a break?" Okay. You want to kill me? I don't think if you're still here, but if you're still here, like, what time zone are you in? I'm kind of curious because I like to get to know my viewers. I know that Sudoku and Sir Nightlord are both from in the Asia time zone. But if you're still here, I'd be interested in figuring out what time zone you're from, so I can maybe accommodate your time zone a bit more. So we're gonna continue any moment now. I'm just gonna check my phone real quick. All right. I have some water. I have some coffee. And we have a goal. So that's basically all we need. So let's get cracking, shall we? Okay, so if I'm going to ignore the Twitch chat for just a moment, we have if I am going to ignore the Twitch chat for one moment. All right, so let's continue, yeah? So, we have a singular goal right now. I'm going to set a timer for 45 minutes so I know that we have done enough work. Okay, we have a singular goal this session. So the goal of this session is to generate some noise. Okay, let's generate some freaking noise. The question is, how much noise? So we have specified the prior on the noise, right? We have specify. So the goal is to decide on the noise. Now we want to generate some noise data. Now the question is, step one, how do we do this? And step two, how much noise should we generate? Oh, this one. Like, how much noise should we generate? Because we have a neural network. If we go back to the to the file here, we input random noise, and the random noise goes into the generator. Now the question is, how much noise do we need here? And if we, again, this puts us in a bind here because we have to make a certain choice, and we are just gonna look at what this guy does. Generator one. So he has 202 layers, 200 and 650. 100 input size, input effector size 100, 10 age, 3 layers, 2 layers, 600, 200, one neat trick, extreme wise gradient decay. Whew, okay, does anyone have a suggestion of what kind of neural network I have to use? If no one gives any suggestions, I'm just going to move forward and generate some noise, let's say input size 100. I mean, again, we have to make a choice at some point in our lives, so let's let's decide on the size of the input vector. let's decide that to be, I don't know, 100. So we are going to generate some noise, and that is gonna be, how much noise are we going to generate? We are going to generate noise number, or observation number noise. What would be a nice variable name for the amount of noise observations? Maybe the good name would be amount noise observations of amount noise. Noise input dimension is 100. Amount noise obs is, let's say, 100. No, let's say 200. Okay, that seems like something we could use, right? So we could use that. So let's call the noise input dimension. Let's call that 100. That seems like a good variable name. Then we have the amount of noise. So noise input features, noise input dimensions is 100. Amount noise observation is 200. And then we have to generate new data, right? So we're going to generate new data. Let's see, he has that over here. Because if we look at the original paper, we generate noise with a minibatch of M, so minibatch of noise samples. And then we train the generator. Oh, this seems rather incomplete here. I do recall that we wrote that we wrote something here. Maybe I forgot to compile it. Let's see. Here, train the generator. So I think we just forgot to compile it, or it's an old version maybe. So we did this yesterday evening. So let's see if that worked. There we are. So here we also sample M. So we could name it M, but I think M is M in algorithm 1. No, that's not this. This is the M. Maybe we can name it minibatch size. Let's call it minibatch size. All right. So let's generate some data, shall we? Random integer slow. I have no idea how to generate data actually using NumPy, but it should not be that difficult. Let's see. We have generate fake data. NP random uniform -1 size. Well, that seems like an intuitive. Z is NP random uniform -1 dot. I'm not sure what the dot is for, but I'm going to copy it anyway. Size equals, what's our size? So he takes a size of 1, and then he takes G input. Yeah, G input. G input is also a nice way of saying that, I guess, right? G input dimension, or G input, is 100. G amount of features, G input dimensions. All right, let's print Z and see whether this works. Okay, let's first start off with not 200, but let's start with like something very small, like 10 here and 10 or 5 here, so that we know it works with only a couple of observations, and then always you can turn it into more observations, right? Yeah, so for some reason, okay, so this is an error that we ran into, uh, and this is an error that we ran into, that it installs Python in a particular manner, which is not as a framework, but it installs Python in a different manner, which I don't recall the name, but we solved this issue, but we had to do something very specific. Let's see. We have that in our notes. I'm really sure we have that in the README here. If we open the README, we learned a lot already. So building this GAN, we already learned so much, like latent samples, generator, discriminator. But it turns out that programming it in turns out to be relatively difficult. So, so instead of Python, we have to use this. So if we run this alias here, that should solve it for the current session. So we have to run this alias real quick. So let's run that. Don't forget to run this alias. We have to run that alias. And now we can finally run Python main. This is something we ran into. In all honesty, I don't even want to learn. I don't even want to use freaking. I don't really care that much about Keras. I can write this function myself. Like, I've spent way too much time on the one-hot encoding and trying to get this to work, while this function is really trivial. I think, honestly, we can just copy-paste it from the np utils. But, okay, so let's see if we just comment that out and see whether it works. Okay, so it reads in the dataset, which we already made a bit smaller, such that it has an easier time. It takes 8 seconds to read it in. And now two categorical is not defined. Sure, that is fine, because we did not do that. I agree with that. For some reason, it takes 8 seconds to read it in, which is a time that is. It used to be 2 or 3 seconds, so I'm not sure what we did. I'm not sure why it's taking so long. Five seconds. Okay, so we finally have some data here. We have, what did we have here? We made 1 by G input dimension size, but we don't want that. We want it by minibatch size, right? Minibatch size. So we generate minibatch size amount of rows, and we generate G input dimension. It's uniform between -1 and 1. Let me write it down. Y uniform -1 1 inspired by J. What's his name again? J Duxo. It's just kind of a magic number. All right, let's see what this looks like. Okay, good. So there is yeah, so this is a 200 by 100 vector of randomly uniformed data, and we are going to sample from this prior distribution every time we try to generate new fake data, right? So goal achieved. We achieved our goal because our goal was to generate some noise. The goal was admittedly very small, but we did that. So we generated some noise. Good. Now we are finished with this. If we were to finish this, what is another task that we could do? We could try to get the generator working. So let's get the generator working. And how do we have to do that, right? So we can turn this into 100. And we can turn increase maybe. So I have to admit, the code is very ugly. It's very, yeah, it's not the, you wouldn't show it to your, you would not show this code to your supervisor or your manager. But if it gets the job done, who are we to judge, I guess? So I'm gonna just take this and put it at the bottom because, no, I'll just keep it here. Reproducible results, split data set, make a plot, make plot of example a number, and here we make a plot, create make plot of histogram of features. Sure. Okay, so prior noise generator, we did that. Now we have to make the generator. Make the generative model. Then finally we have to make the discriminative model. Right? So, what is the generative model? The generative model is a neural network. So we are going to have G and we're going to name it neural network. Because we have this class here somewhere. We have this class here. Let's see if I can edit that file. This is the GAN. So we have to make like a neural network. So we're going to have to import that. Then we have X and Y, where X and Y are, X stands for the input vector, Y stands for the labels. Okay, so we do use the labels over there. Sorry for thinking so long, but I have to get something straight in my head right now. So if I were to think out loud, this is what it would sound like. So we, at some point, we're going to have to program in the generator. And the generator, we have to program in a certain loss function, right? So this is the neural network, and for the feed forward, we can calculate some loss, and the propagation is rather easy. So the propagation is rather easy, but the back propagation depends on the loss function, because to back propagate, you take the derivative with respect to the loss function, and you either add that or you decrease the weights with that certain number. Now the problem here is that we have to find out what the loss function is for this excuse me, sorry, for this particular thing. And as we can see here, we use the labels and the feed forward predictions. So we use the labels and the feed forward predictions. So these are like, so the backpropagation is a function of all the weights and the predictions and the real labels. So again, we come back to the question, what are the real labels? What are the real labels in this case? And I think my current vision on this is that, or insight, whatever. So we actually did this. We also did this. So my current vision. So my current vision or idea or understanding is that the label associated with the newly or fake generated data is not the label as in the number 0 through 9, but instead all zeros, all fakes. So the label Y that we assign to the generator is 0. Okay, and we want to train the generator with backprop. We need to have access to the discriminator, because the loss function of the generator depends on the probability outputted by the discriminator. So actually we have to start by programming in the discriminator, I think. So we don't want to start with the generator, but we have to start with the discriminator. So let's try to get the discriminator working. Let's revamp this goal actually. So instead of getting the generator to work, we are going to try and get the D to work. This should be even easier, because the only thing we now, so let's get back to this thing here. So instead of getting the generator to work, let's get the discriminative model to work. So we already had quite some specifications of what the discriminative model is going to be. It's going to take in an input vector of 784 by 1, which is a 28 by 28 pixel values. So 28 times 28 times 1 pixels. Output is a single number real, the probability of the image being real, right? Usually you have XY features, but now we have XY real fake. So when we are training the model, we know which ones are real, we know which ones are fake. Yeah, so this is just your standard neural network actually, right? So there's nothing special about this. So this is just a standard neural network. I mean, we input some training data, we know all the labels from it, right? So we can just like copy paste this. We can just copy paste this actually. But then if we import this class, are we gonna miss? So from okay, let's see. So from neural net, import. All right. So my question now is, is this gonna work? Let's call it X train and let's call this Y train. We have 4 hidden layers. So I want to see if this works because we are not importing. Ah, shit. No, wait, it's fine. So we did not import the logistic function. And I'm wondering whether that is going to give us some trouble because they're used in the neural network file. I don't think, no, so it doesn't give any issues actually. So we can, for example, now print like, what is it? I think it's called output or loss or output. All right. All right. So, that is the neural network. And it has to output a number between 0 and 1, right? And I think actually we do not have to change anything except for the back propagation here because we use a different loss function. So maybe I don't know what is the most Pythonic way of changing this because the neural network, maybe I can call it like neural network I don't know, discriminative neural network, right? Or is there any way I can like invoke, like, I want to know if there's a different, like, I want to keep all this code, but I want, so yeah, let's make two. I'm not sure if this is very Pythonic what we're gonna do here, but we are gonna make two new functions. We're gonna make a feed forward function. So okay, let us quickly convince ourselves that this self loss is not right anymore, and we are going for the GAN model. So we are going to make a self loss function and call it GAN loss. Is, let's say, 0. So self GAN loss is 0. Let's instantiate that at 0. So this is for the squared error loss, right? And this is gonna be for the GAN loss function, where we have I think we can type that in. We can type this in because we have all the things here. So this is the loss function. So we so this loss function can be set as like np log, and then I don't know, dx. We're gonna change this. Plus np log 1 minus dgx ggz. So Geez. So we are going to have to split this. We're gonna have to split the loss function into the real data and the fake data. So we're gonna split this up into where self y is 1 and self y is 0. So this is the fake generated data and this is the real data, right? We could probably do this in one smooth motion, but currently I'm not really seeing how. So we're gonna have to split this up because if the self y is 1, that means we are dealing with x's, right? So we have x's. You just get the dgz, so you get log the 1 minus. Yeah, so what you wanna write down in the end is log if self y is 1, then you wanna add to the log and then d x values, which is a number, and if self y is 0, you want to add log 1 minus d x, which is a number, where x is of course generated fakely by z. But we don't know that because all that we see is okay, we could actually this is not too difficult. I think we can do this with not with an if statement, but just with a kind of matrix multiplication thingy. Shit, but this is for the generator as well. This is for the generator. Huh. Geez. Let me see. Excuse me. So, we have to make a choice here. Something either we're gonna generate two new functions. We're gonna generate feedforward underscore g, because we're also gonna need okay, maybe we can not name this GAN loss, but maybe we can call it a discriminator loss, right? So discriminator loss, D loss for the discriminator. And then self G loss. So the generator the input for the generator is the random noise. So these things right now are a bit pseudocode, right? These things are a bit pseudocode. Okay. Yeah. So let's generate a backpropagation. Let's create a backpropagation function for the case where we use our different kind of loss, where we have a different kind of loss function, right? So we are going to copy this function here, and we are going to name it backprop for the discriminator. Then we're going to have to specify the loss function, and we are going to have to change these two, and we are going to ascend the stochastic gradient. Let me see if we actually ascend or we descend the stochastic gradient. We're going to ascend the stochastic gradient, so we're going to add this. We're going to add this number to the gradient. So we have the minibatch here. So we only sample a random subset. So we sample a random subset of the observation. So first we are going to sample a random subset of the observations. We're going to not take everything of them, but we're going to sample a random subset. And then so the loss function is going to be the expected value over the minibatch of log dx plus log 1 minus d gz. And we're going to have to do d weights 2, d weights 1. And this works. So now we are going to have to take the derivatives of the loss function with respect to the parameters here, and we are going to use the equations from this guy to do that. So we are working on the discriminator right now, which is this one. And I think he implicitly assumes that the biases are also 0, because I don't see anything with respect to the biases. So at least we are going to assume that the biases are 0. So depending on whether the data is real or the data is fake, we get a different addition to the loss function. Okay, so I'm just gonna program this in kind of in the same style that he's doing. I'm gonna say so I'm gonna say L1. So this is gonna be the input for the first hidden layer. So this L1 is gonna be the inputs for the first layer, for the first activation layer. So we get the data, we get the input, right? We get the features. So that is self layer 1t. So that is self layer 1t. That's the matrix multiplication. Self layer 1t times the weights. Times self weights 1. So this is gonna be the inputs, and now we are going to have to be a bit precise with the dimensions. So self layer 1. So layer 1, self layer 1 is a sigmoid of the self input and the self weights 1. So self weights 1 equals input times hidden node. So this is like times self hidden nodes. So the size. So I'm looking at the size of this right now. So and self input is x. So we take the self input shape So we take the self input. So self input is either 1 times something or something. So I think we want the self input to be a row vector. Yes, we want the self input to be a row vector. So 1 times. So we have self hidden nodes, and I'm gonna write this down. So self input equals 1 times number of features. Then self weights equals number of features times self hidden nodes. So we want the self input is and then wait a second. So the matrix observations is n times the feature. So it's not. So we ran into this problem the first time building the neural network, where we were confused about the dimensions of everything. So x actually is an input. Is like we input. So we have n observations, and we have a lot of features. So this is also going to be a matrix. So this weight is going to be a weight matrix, which makes this also a matrix because the input is a matrix. So this is going to be like the sigmoid activation over a whole matrix. So that means that we wanted to do the data times. So the data is going to be data is n observations by features And then we have, so that is self layer 1. Self layer 1 is the number of the times hidden nodes. And the weights are indeed hidden nodes by, is the input shape 1. So I think we have to transpose the first layer. And self weights 1 is the features times hidden nodes. So self weights 1 is features times hidden nodes. And layer 1 is the dimension of layer 1 is, I think, observations times features. Observations times hidden nodes. So it might be that we don't even need to So it might be the case that we don't even need to do this over here. So we don't even need to transpose it. So let's see if this works. Let's sequentially keep asking ourselves whether this works. So if we run this now, let's see if we run into any errors. Okay, so as of thus far, no errors. So my timer just went, so we have another cycle. So what did we do? We generated some noise and we started thinking about how to change the neural network code such that we can accommodate the new backprop for the new loss functions that we have. We started to realize that we need to work on on model D first, because we need access to the predictions of D to train G. Any distractions? No, not really. Things to improve next cycle? I don't know, you tell me. So this is the ending time. Whoopsie daisy, that's my bad. So ending time is 9:57. Alright, thank you so much for joining me. So if I have some new viewers, which I don't think I have, but we are building a GAN today, and hopefully we can finish it today before I have to go. So we just finished another session of 45 minutes. I'm gonna take a very quick break. I hope you guys are willing to stick with me here. I'm gonna take a quick break, and in the next session we are hopefully going to finish the backpropagation algorithms for the discriminator. So we are gonna sequentially program in all these equations one by one in our own version, because we don't use ReLU, but we use only sigmoids. And then hopefully it works, because we have to separate the real images from the fake images. So yeah, hopefully you're willing to wait 5 minutes or 10 minutes and until I get back. If not, I was very happy and glad to have you here, and hopefully you will be able to tune in next time. Alright, so I'm gonna take a quick break, 5 to 10 minutes, guys. I'll see you soon. Alright, I'm back. I hope, sorry for the long wait, guys. I had to do some stuff downstairs. I hope someone's still here. But even if nobody's here, I'm still gonna stream anyway. So, yeah, so this stream is gonna be a bit boring, the next session of 45 minutes. Because I'm gonna work, I think, mostly in silence, because we need to, I think I need to get working I want to get the backprop working, but the backprop requires some math, which is relatively difficult, so I'm gonna see if I can program that in. I don't want to say in complete silence, but I'm gonna be relatively quiet, so, but hey, I mean, it doesn't seem like anyone's here anyway. If you're here, feel free to send me a chat message in the chat. I'll respond to it as soon as I can. If you have any other questions, you're always free. Please don't hesitate. I'm more than happy to answer your questions. So I set the timer. I'm going to put on some music and I'm going to get coding. So I don't think you guys will be able to hear the music. If my... if my Spotify weren't crashing. All right, thank you so much for joining in today. In this session, we want to program in the backpropagation algorithm for the discriminator. That is our only goal. Our only goal right now is to program in the backpropagation for the discriminator. So let's program in the backprop for the discriminator. That's our only goal. If we were to finish this, what could we do? We could test it out. How will I get started? Look at the math and convert that to our math. What hazards? Internet, phone, etc., etc., etc. All right. I was gonna blast some music, but my Spotify seems to have a hard time. Starting up. If I can't do it on Oh wow, really? Okay. So Spotify doesn't work anymore. So Spotify actually blocked my Spotify. I have Spotify Premium now, but I used to use Spotify free. Spotify. So I'm gonna blast some music and I'm gonna get coding. You guys won't be able to hear the music, but if you have any questions, if you just joined in and you have no idea what I'm doing, feel free to post a question in the chat, and I am more than willing to help you guys out, get up to speed. Because we spent already quite some hours working on GANs, but I'm more than willing to repeat everything. All right. All right, so okay, self layer 1 is not defined properly. So xtrain Okay, so we have to reshape the training. Let's get rid of this for 1 second, right? So what does xtrain now look like here? Yeah, so actually, before reshaping, the shape was fine, and then we reshaped it. We reshaped it because the tutorial did so, but there's actually no reason at all to reshape it. So there's no reason to reshape it. So yeah, we did that maybe to plot it a bit, but um, no, we don't need this. So the input dimension is 784, which is 28 squared. Not now. And then how many observations are we going to generate? Let's say we train equal observations. So we're going to take x train. We're going to take x train observations. So let's take and then let's see what y train is. Let's print y train head. I'm not even sure if head is a valid thing. So y train is just an array, right? Or a data frame. I think it's just an array. Oops. So Y train is a head or a thingy. And then we got an error. Well, what error did we got again? So So, so this is the part where we don't put in. We put in the real ones get a 1, and the fake ones get like get a fake. So the X train is we're gonna expand the X train. We're gonna stack 2 frames. We're gonna stack 2 arrays on each other. So we're gonna stack Z, and we're gonna stack it with the X train. And now I'm not sure whether this is even allowed. So if we have temporary, can we just stack like 2 arrays? So np random, what does np random return? How to stack 2 numpy arrays? So it returns random floats or an array of random floats. And we're gonna have to stack the arrays here. Take a sequence of arrays and stack them vertically. Rebuild arrays divided by v-split. Yeah, we're looking for... Yeah, we're looking for stack. We're definitely looking for stack. So let's take np stack, like np stack. And we have to input a tuple actually. Of X train and Z. Let's try that. Let's print TMP. Let's see what we get from this. Let's see if we get any error thrown in our face right now. Ah, excuse me. Okay, that's cool. Then then we need to make like the labels, like, so this is gonna be X train, right? This is gonna be so X train, fake and real, and then we're gonna have like Y train, fake or real. And this is gonna be a vector of ones. How would you make a vector of ones? So, or array. NumPy ones. So this is gonna be NumPy zeros, right? So if it's from real, it's gonna be NP ones, and this is gonna be, we're gonna have to put in a tuple though. NP ones, and this is NP zeros, where NP ones the shape has to be no times 1, something times 1. And here we get X range shape not, and we get Z shape not. So here we assign 1 to real image, 0 to fake image. Here we stack real and generated images. All right, let's print Y-train fake and real. Let's see what happens. So we're building up the matrices very slowly here. Data type is not understood. Empty, A is empty. Okay, yeah, this has to be tuple. So this has to be tuple, I think. Running is getting a bit slow, eh? Awesome, so that worked. So let's take some time. So the shape seems correct, but let's also look at the shape of shape and the print X-train fake or real, right? We want to also know what the shape is. X-train fake or real shape. And here we have Y-train fake or real shape. And then in line 84, so it starts erroring here. That's really good, right? Everything will be just fine. This is weird. Why is the shape 2? Why is it 2 times? This is so weird. Why is it 2? I don't want it to. It should not be a 2 here. It should be like this and this, this and this. All right, so this doesn't work. Let's try appending this then. Let's try appending this. Oh my god. Oh. Whew. Actually, reading in the data set is really annoying. Okay, so that didn't work. So now it kind of flattens. It kind of flattens everything, right? What if x is 0? X is 0 is if x is not there. Oh, alright. So, okay, what did we learn? If you don't specify axis, it flattens it, right? So let's say we put x is 0 there. All right, this is good. This is exactly what we need. We want it to have like that shape, right? That is the shape we are currently looking for. This is the shape we need. That's great. So we can do the same for this thing. We don't need to stack it at all. We just need to append it, but with the proper axis. So you wanna append NP1 shape, and you wanna append. There's a lot of brackets here. So this should work. Oh wait, of course it's still in a tuple form. We don't want this in a tuple form. We just want this in a, so this is fine, but this is an array. That's an array. This should work. All right, finally, we got the proper shapes for the combined fake and real data trading set. So that is an array of 15,000 by 800 are the fake features and the real features together. And we have an array of 16,000 roughly by 1, which is all ones or zeros. They are 0 if we generate it, and they're 1 if it's the real data. So this is the stuff we're going to input in the discriminator model. So we don't need this anymore. So we need X train fake or real, and we need Y train fake or real. Fake and real or fake or real? Let's make it and real. All right. Then we can train that, and now we have to change the feed forward and the back propagation algorithms. So yeah, so the feed forward algorithm is actually roughly the same. So if you go to the feed forward here, this is in the neural network. So the feed forward is going to be exactly the same because we just use sigmoid activation. So we're just gonna update the output, gonna update the first layer, and we're gonna update the loss, and we will have to get rid of this loss here. But in general, that is the we can just feed forward. So feed forward is not that difficult. We can just call the feed forward algorithm. but then this is the difficult one. So the backpropagation is where the difficult stuff is going to happen. So we're going to have to rewrite the whole backpropagation algorithm, and hopefully this doesn't give an error. If this doesn't give an error, then we are on the right track of programming in the backpropagation. So let's see if that gives an error. If it does give an error, we most likely have to get rid of the transpose because the dimensions have to match up, right? So, hey new viewer, I saw you tuned in. If you have any questions, feel free to post them in the chat. This session is going to be relatively quiet because I have to program in the backpropagation, and that requires some concentration, right? If you have any questions about GANs or just want to hang out, feel free to join in. So the shapes don't match up, right? So these are the features. These are like the 100 features we have. Why do we have 100 features? That is silly. We have way more than 100 features. Why am I generating? Why do I get 100 features? Self layer 1T. Okay, the 100 are the hidden nodes, right? Because we took 100 hidden nodes. We have the weights times the data. Uh, I'm gonna write this out on paper for 1 second. Give me a second. Because this is important to get right. Because these are the dimensions, right? These are the dimensions of the model here. Where is a pen? Or like this. So we input, so the input is a vector of 7, if like n times 784. Then we come to the middle layer where we have 100 hidden nodes, and the output, like the output of this thing is gonna be n times 100. But how are we gonna get there? We're gonna get there by multiplying all the weights. So you get n times 784 times 784 times 100. And this is 784 times 100. But I don't know why this is 100 by the number of observations. Because this should be, layer 1 is like, layer 1 is not what it should be. No, wait, layer 1 should be... Okay, so layer 1, the dimensions should be the observations times the amount of hidden nodes. So that is 15, that is n times 100 in our case. And is that the case? Yeah, so layer 1 transpose is then 100 times the amount of observations. So layer 1 is correct. But we don't need the weights at all, because so that is already like layer 1. Okay, so layer 1 is, I just took the equations as given, but we don't need this. This is our self layer 1, like that is the output already. So layer 1 is self layer 1. That seems really redundant, but okay. Then if we go back to the equations, so this is actually layer 1 activation already. This is already L1A. Then L2A is going to be the sigmoid over L2, where L2 is self layer 2. Which we also call self output, I guess. All right, let's see how much error we get now. See, like, it takes significantly longer than to program it in yourself, right? Because you have to do everything yourself. I do think it's a very painful exercise, but also a kind of a fun exercise in a way. All right, so we get no errors at all. That is really good. Which kind of makes sense. Okay. Then I'm gonna calculate. So these are layer 1 activation sigmoids over inputs times weights 1, and this is the sigmoid over inputs times over layer 1 times weights 2. So we are going to create. So we're gonna take calculate d weights for real image, and we are going to calculate d weights for fake image. D weights to, let's say, fake, and here we have d weights to real, because this is not too big of an operation, right? Yeah. So we are going to take these formulas. So we have minus 1 times minus 1.0 divided by L2A times the derivative of the sigmoid times the first layer activation. So I think I have to like I have to take the because so the input is like, so now the question is like, what is the input here, right? I think it's self-output, but I think it's more clear if we put L2A here, because that is exactly the same, it's self-output, but that is the argument that we invoke. So what do we multiply it with? We multiply it with L1A actually, so I think it should be like this, L1A, but now we have to make sure that the dimensions are correct, because the dimension of L1A is n times 100, because it's the sigmoids over the inputs times the weights, and this, the input of the of this is actually I think it generates a single number, right? So this is going to be n times 1. So if we have the sigmoid derivative is just a function. The sigmoid derivative is just a function which returns the same dimensions. So let's see how much errors we get thrown at our face in this case. Okay, so the shapes are not matching up. Because L2A, of course, is n times 1. And in the end, but L2A is a big number. L2A is a big number. Oh, I'm trying to add this here, right? So sigmoid derivative L2A, like what do we want this to be? The second set of weights is a matrix of 100 by 1. So we want this to be. Am I missing? No. Want should be. Dim should be 100 times 1, right? So L2A is indeed 100. No, wait. 100 by 1. Wait a second. But L2A, L2A is 100 by 1. So L2A is like, the dimension of L2A is fine. No, wait, it's not. No, L2A is 1 by 1, actually. So L2A is n by 1. Sorry. So L2A is n by 1. And we want this thing in the end to be 100 by 1 because we want to update L2A is 100 by 1 is the output of the final. Then we have to look at the sigmoid derivative of L2A. Wait, I'm just gonna print out what L2A like. Print L2A shape because I'm kind of getting confused here. I'm gonna turn down the music a bit as well. Hey, welcome new viewer. I hope you're enjoying the stream so far. We're programming in a generative adversarial network. We spent already quite some time learning the theory, and now we're at the process of programming it in, but it all turns out to be a bit more difficult than initially expected. But hey, that's beauty, right? So the shape of L2A is n times 1, okay? Is the amount of observation, so all the stuff that comes into the second okay, of the final activation layer. So L2A, is that the output of the final activation layer, or is that yeah, so that is the output of the final activation layer. So that is L2A. Okay, then the sigmoid derivative of L2A has the same shape, right? It must have the same shape because we just applied the sigmoid activation layer over that. Okay, so that has the same shape. But what we want to do here so we want to use all the observations, or at least the mini-batch observations, right? Let's just forget about mini-batching right now. So we want to use all the observations. We want to use the n times 1 observations, use n times 100 observations to make a 100 times or hidden nodes times 1 vector of weights. So that is the algorithm here, and L1A is times 100. So sigmoid derivative is okay, I'm gonna write this out. So if we have minus log L to A in the d cost, and we take the derivative of d cost, like minus log L to A, like L to A is like n times 1. So taking the derivative is only possible if you take the derivative. I'm writing it out here on paper. Like taking the derivative of an n times 1 vector is only possible if you take the derivative with respect to like a transpose. So we take the derivative of delta like d cost, take the derivative with respect to like the transpose of dw2. So I actually think if dw2, if we take that to be like a column vector, which seems natural, which we do as well, we take it to be a column vector, then there should be a transpose here. So if you want to be like mathematically correct, there should be a transpose here, because you cannot, or well, it's unnatural to take the derivative of an n times 1 vector with respect to another like direction downwards. So then you would get an n times the amount of hidden nodes, which is very unnatural. So then if we write that out, you get the derivative of like L2A1 with respect to delta W21, etc., etc. You get delta delta 2A1 with respect to delta W2 2 times 100, etc., etc. So you get an n. So that would result in an n times 100 vector, or n times a hidden node vector, as follows. And then you would multiply that thing. But you don't really want this. You want the transpose of this. Yeah, so you want the transpose of this. So you want the transpose of d cost over dw transpose. You want the transpose of that. That is 100 times n. Then you want to multiply that by the derivative of the sigmoid activation layer of L2A, where the derivative of the sigmoid layer is n times 100. No, this is very confusing. Oh, this math is significantly more confusing because people are not being very precise with this math. Okay, I'm gonna take a quick break. Did we program in? No, we weren't able. No. Like, yeah, good question. What did we do? So we kind of worked on the backprop algos, but weren't able to program. No, no. So I'm gonna have to go right now. Thank you so much for tuning in, everybody. I hope I was able to learn something a bit. Sorry for being so vague. Like, I wish I could explain it better, especially the backpropagation algorithms, but it turns out that I'm having some difficulties understanding them myself. So I might just spend some time off stream trying to really understand it so I have a better and easier time explaining you guys what backpropagation is, or rather what the what it looks like here in this type of GAN model. Because as you can see, you have to be really careful. Look at all this. You have to be really careful with all the equations. So yeah, I have to go now. I hope I provided some entertaining content and some educational content at the same time. If you have any questions, feel free to shoot me a message, post in the Twitch chat, or if you like this kind of content, please don't forget to subscribe. Don't forget to follow me. I would greatly appreciate it. That would motivate me to make even more of this content. I will spend some time off stream. Oh wait, I had another task. I had to make like You Wanna Kill Me said I had to make like social pages. So I will also try to get set up maybe Facebook. And I'll upload the VODs to YouTube so you can watch them there, and I will link them in the description below. Yeah, so for those 2 new viewers that just tuned in, I'm actually gonna stop the stream now, but you can watch my VODs. And in the first stream, we make a neural network from scratch. Then in the second, third, and fourth, and fifth stream, actually, we are working on GANs. And it turns out that I'm having significantly more trouble programming in GANs than a neural network, while they are not necessarily that different. So I feel like I'm doing a poor job of explaining GANs to you guys, so you probably think it's way too slow. And I'm gonna spend some time off stream trying to maybe write up a prototype such that I can explain it better to you guys. If you have any questions, don't hesitate to post them in the chat. I'm more than willing to explain everything all over again. Yeah, I had a great time personally. I like literally rolled out of bed and got the coding, so I really enjoyed doing that. I hope you guys enjoyed that too. And I'm gonna wave you guys off now. Thank you so much for joining me. Hopefully you will follow me and join me the next time I stream. My streaming schedule is quite irregular, but I'll try to make it like somewhat more regular. So yeah, thank you so much for having me. I enjoyed having you guys, and hopefully see you next time. I apologize for shutting off the stream now because you guys just tuned in at like the last moment, right? I'm so sorry for that. All right, hopefully you guys are willing to check me out next time as well, and hopefully we can get more done the next time. Thank you so much for joining me. I'm gonna stop the stream now. Thank you. See you guys.